How's it going, everyone? I'm Dustin with Hard Cruise Racing. Today I want to talk real quick about what you might experience and the things that you need to do if you were going to have a part 3D printed. Now, this could be a part for your car, your motorcycle. It doesn't really matter. And I'm specifically talking about working with a 3D printer in this video. I want to make it very clear that you're going to have to do these same things if you are going to 3D print it, some things you're going to keep in mind, and so on. Now, first and foremost, I am not going to say the name of the person that I used for my 3D printing project. He does really cool high-end like anime, some masks, some like things to hang on the wall, stuff like that. Really high-end work. Okay, I asked him to do a motorcycle part, which was completely outside of his realm, and I'm happy with the outcome that I'm achieving from him. Okay, I have one more rendering that I need to get done, and I'll explain that along the way. So, first and foremost, this is the part that I needed made. This part right here goes on my wife's motorcycle, the one right here. And in the winter, when it was cold, it snapped off from here. You can kind of see in there where I've glued this one back together, but it snapped off. So essentially, this sits inside the grip, and there's a coupling that sits over top of this, and when it's moving back and forth for a long period of time, it just slowly wears through there, and eventually it's going to break because it's plastic, it's in the sun, it's in the wet, and it's just rubbing back and forth and back and forth and back and forth. So hers snapped right off. I kind of put off getting a new part because it wasn't riding season. It was the middle of winter, and I was just starting the bikes up, moving them around to keep everything flowing. So the part snapped off. I went on Amazon and I tried to order a new part, and I specifically put in the bike year, make, model, and a part came up, and I said, okay, great, I'll buy that, and then it did not fit. Did not fit over the tube at all, so I couldn't use it if I wanted to. Or no, it fit over the tube, and I put that coupling on there. It was too tight, and it wouldn't seal. It was locking the whole thing up. That's what it was. So clearly not going to work. So she went on eBay and ordered a part off of another old bike. Now, keep in mind, her bike's 15 years old or something like that, and the part showed up, and it had the exact same crack and break about to occur. It's this part, and I could grab it, and I could pull it, and you could see the gap opening up. We decided that it wasn't worth the risk of going out and getting stranded somewhere to risk an old part. That's kind of where we came up with it, is this part's about to break. I can do something to try to fix it. But if we get on these bikes and we go out somewhere and we're 3 hours from home and her bike breaks down, she can't jump on the back of my vintage race bike. There's not a rear seat. There's not rear pegs. There's none of that. So she can't really jump on the back of my bike. So we decided to reach out to a 3D printer. Essentially, we have a big motorcycle charity event coming up this weekend, and we had somebody already coming out to do some projects for us, and we said, I wonder if he can make us a motorcycle part. So the original part, this is the eBay part, the original part was still broken, and I took that piece to him, and I essentially said, this connects to here, this is what I need. I disassembled the part, so this rubber grip, which you can see here, comes off, and this trim piece comes off. So I disassembled the part and I handed it to him, just the two pieces. And I said, do whatever you want with it, put it together, figure it out, but I need this part. A few days later, he comes back with this rendering. Now, again, I handed him an original part. I left it up to him. I didn't care if he scanned it. I didn't care if he measured it. I didn't really care what he did. I just said, this is the part I need. So he came back with this part. Now, everything on this part, now, this isn't a finished part. This is just like I made it out of the weak material that I have. Both of these purple ones, it's made out of a weaker material. It's more cost effective for him to print, reprint. He said this was about his 8th take on it. He said his computer would not run 3D scanning, which he tried to do. So he gave up on that and he tried to put everything in manually. Great on him. This is an 8th take, and when I put it on there, everything was a little small. It won't go over the tube. When I got it in there, that coupling gap was a little loose, and this trim piece that goes on here, if you look, when it goes on, is also loose. One of the things that I don't think the 3D printer had considered was part shrinkage. When you heat up a part, when you put it into a printer, it shrinks just slightly. Everything on here was about a half mil off, I think. Again, I don't know what measurements he used, but when I measured it, everything seemed to be about a half mil off. So I sent everything back. I essentially sent him some pictures, and I said, add plus 1 millimeter here, plus half millimeter here, plus half millimeter here. And he sent me back a part. Now, Here is the new part. Here's what I'm going to say. The reason that I told him, I didn't say make this exactly 32 point whatever millimeters, was because I needed him to add to the measurements that he had. Okay. Now we're talking about shrinkage. Okay. This is one of the things I want you to think about. This is a cheap mic from Harbor Freight, like a cheapo one, less than $10. Like you turn the on button on, and it's on. You make sure it's 0. There's your measurements going all the way up. Okay. It says you can go to inches. I have never. Oh, it just switched. That's the first time that I've ever hit that button and it has switched over to inches. Never happened. So, anyways, I asked him. I said, "You want your measurements in millimeters, inches, what?" It said millimeters. So, what I did, I took this part and I started measuring the parts that I needed. Okay. Here's one of the originals. So I went in here and I said, okay, that has to be, and I'm moving it around, trying to get the largest measurement, 26.8, 26.9, so let's say 27 millimeters. I went over and measured the bar, okay? And here's the bar. 25 millimeters. Okay, so now I got 25.2 to 27. I need a 2 millimeter difference gap for looseness for be able to rotate. So then I measured the part that he sent me, this one. And I'm like, well, we're only at 25 and a half. Okay, 27, 25 and a half, plus 1.5 millimeters. I need that, okay? New one, we're at 26. So, again, it's getting there. I'm sending him final measurements and I need to adjust it. So I did this with every single part. I did this with well, before this was on there, right? So I took this trim piece and I took a measurement of the inside, and I'm like, okay, that's 35.5 millimeters. I went over to the part he had sent me, and I said, that coupling sits here, and that is currently at, whatever, okay? So this is the game that I played with the whole part, one step at a time, and I had to know in my head that everything can't fit with 0 tolerances, right? So I might need a 0.5 millimeter difference between this part and this part, so that way when I slip that over, that part sits in there, and it has a little bit of play, okay? So let's see. That was the part he sent me originally. Here's the one he just sent me, the new rendering. Slip that on there, and now I have less play, okay? And I'm happy with that, because I want a little bit of play in there, just so there's no binding. Now, I could get this piece to press fit, but if something needs to move, such as on that pipe, then I need to make sure I have more of a gap, more of a tolerance. You as the individual need to know this. This is not on the 3D printer, because I feel like a lot of times you're going to send something to the 3D printer and say, make me this, and he's going to make you exactly that, or he's going to make you, and he's not going to know about maybe shrinkage, because in 3D printing world, you print what you print and the size that it comes out of, you're happy with it. In the automotive world, when I say that I need specifically 32.2 millimeter internal diameter and 35 millimeter outer diameter, I need those measurements, okay? But that doesn't happen in the 3D printing world, okay? So this is where you as the individual comes in, and you need to say, hey, make me a rendering, and then I'm going to test it, and I'm going to bring you back measurement adjustments, and then you need to do it again. Make that very clear up front if you're going to deal with a 3D printer, especially one that doesn't necessarily deal with automotive parts. Now again, these things are very much to the automotive industry, and no other place are you going to have to really concern about that unless you're trying to make a clip that goes onto something. But again, 99.9% of the time for 3D printers, if they need a clip that goes to a specific device, they're going to Google it, and somebody's already going to have made the file. It's just what it is. So here's the most recent rendering that he had sent me. This tubing fits all the way over except for one spot, and that is where, when he was building the parts and overlapping circles and all this other things, you look inside of there, there's a very small ridge. You see that? Well, that small ridge is just enough to not slip over that pipe smoothly, over the handlebars right here, smoothly. So for my final rendering, he's about to build the part out of a higher quality plastic that is a little less brittle, a little more durable, things like that. I just said get rid of that inner ridge, get rid of that, or I can sand it out. I really don't care, but this is the part I need. And with this part being essentially what I'm going to get, I know that trim piece fits with a little bit of slack in there. I can glue that if I want, and I know this grip will go on nice and snug like it's supposed to. And if I wanted to add a touch of glue, I can. But my part is essentially done, other than being made out of the wrong material. The reason I'm making this video is because I think that there's going to be a disconnect between you as the automotive guy and the 3D printer. Or if you're a 3D printer watching this video, don't be surprised if there's a disconnect between the automotive guy and the 3D printer, or if he blames you for dumb things. Because things like material shrinkage, or things like improperly measuring what the part needs to be. Like if I measured that bar over there and I was like, it's 32 millimeters, and I told you, like, I need inner diameter of 32 millimeters, that part will not fit. I need that to have like a 1 mil spacing, 1 mil gap, so that way this, when it goes on, can rotate because it's not a press fit. So the 3D printer needs to communicate with the automotive guy, and the automotive guy needs to have a very decent knowledge of what needs to be press fit, what needs to not. I need to know that this as a rubber material has the ability to flex, and so for this to be a tight fit on this, I physically need this to be tighter than the inside diameter of that, which is what the ridges are for. The 3D printer is not a car guy. He might not know that. He's not a motorcycle guy. He might not know that. This doesn't flex at all, so I need that to be slightly smaller than this, so that way when that goes on there, it slides all the way down and it stays there. I know that. Does my 3D printer know that? Maybe. I don't know if he knows that. If he's not a car guy, he's not going to know that. There's also this end cap, which I did not bring into account at all because it's not a close fit thing, but that's going to go over the end too. Like, if this distance is wrong, if this length is wrong, I didn't check it. I'm going to sand this, and I'm going to be okay with that because I know that I need to do that, and it would just be more things that I would be giving to a 3D printer that don't necessarily need to happen. So look at this as like a almost done part, but maybe not a completely perfect part. It's probably best that my phone died because I was going off on a little bit of a rant there. The point of the whole thing is that everybody doesn't have the knowledge that you do, and you don't have the knowledge that everybody else does, but coming together, we can make some pretty cool parts and pretty cool things. I think after this whole experience of trying to get a part made for about a week and a half, which again, partial my fault, partial just turnaround times, partial all of that, I think I might consider buying a 3D printer because I think I can make some pretty cool things, just trial and error kind of stuff. But who knows? Who knows if that's what I really want to go down the road on. My point of the video is give as much information as you can, even if you don't think it's necessarily relevant information, and work together. Try to find somebody you can work with, because the guy that I'm working with to get this part made is wonderful. Wonderful on the fact of, like, I sent him precisely add this. It wasn't a question. He just did it. He brought his expertise to the table on materials. He brought his expertise that I did not have about plastics, and I brought him measurements and exactly what I needed. So, yeah, I'm going to go pick up my final part here made out of a better plastic here in like a day, and then I'll have that installed, but I'm not going to do it in this video, so yeah. Alright, get out there, build cool things, and most importantly, have fun and have a good day.